Welcome to our demonstration of VMX for Deadline. VMX stands for Virtual Machine Extension. It's for Deadline 6.1 and later. The theme for VMX is Render Anywhere, take full advantage of public and private clouds. And in the course of the demo, I'm going to show you how to do that. In order to explain how VMX fits into the Deadline ecology and history, I'd like to show you some of the history of Deadline. In Deadline 5, we had the classic render farm situation where you had a repository and then you had a set of artist workstations and a set of render nodes. And on the artist workstations or the render nodes, you would have your operating system of choice installed. You would have Deadline Slave installed, and then you would have your suite of applications that you would be using for your production. With Deadline 6, we introduced the ability to spin up VM instances on the Amazon EC2 public cloud, although it was necessary to spin those up manually. We also added the Mongo database to Deadline 6, which makes Deadline go from being fast to being even faster. With Deadline 6.1 plus the VMX extension, we added the ability to talk to nearly any cloud solution as long as it has an API. And that includes, for example, public cloud solutions like Azure, Cloud Foundry, Cloud Sigma, Rackspace, and so forth, and private cloud solutions like OpenStack, OpenCloud, and Eucalyptus. And in addition to being able to talk to these various clouds, VMX has the ability to spin up the VM instances automatically instead of manually. It's important to note that cloud support in VMX is purely additive to your existing farm. That means no changes are necessary to your classic render nodes and workstations, and you can seamlessly mix cloud and non-cloud rendering. You can transition over to the cloud usage at your own pace. So let's look at the queue. So here's a typical Deadline queue with various random jobs in place. If I draw your attention to the lower panel where the slaves are listed, TB1 through 4 are classic render nodes set up as you would in any typical farm. In our Winnipeg office, we've also set up a small private cloud using OpenStack. And already we are running 4 render slaves on 4 VM instances, OpenStack 1 through 4. And if you look at, for example, one of these jobs, you can see that our OpenStack slaves are participating in the rendering. To find the cloud settings for VMX, it's in the Tools menu. For Deadline 6, the cloud configuration was under Configure Cloud Providers. Currently in 6.1, it's under Configure Cloud Providers VMX. So I'll open that now to show you some of the settings. So here, for example, is our OpenStack setting. You can see the basic configuration options for each cloud region, such as the ability to enable or disable the region. The region preference, which lets you control the order in which regions pick up work. And that way you can have, for example, a private cloud configured as well as a public cloud, but have the private cloud pick up work first and have the public cloud pick up work second. There are also budget controls, which I will talk about over the course of the demo, so that you can limit the use of resources or the amount of money spent on public clouds. And there are asset checking features as well, which I will also discuss in this demo. You'll probably notice right away several cloud providers listed. The point of doing that is to show you that we can connect to almost any cloud solution. For example, let's turn on Amazon, and let's also turn on Azure Public Clouds. We'll get those started. And while those are going, I'll return to the presentation and talk a little bit about some advantages of private clouds. One of the reasons you might want to use private clouds is that you can configure virtual machines that are tailored to each application. And what that means is that in a classic render farm where you're installing the operating system, the slave application, as well as the suite of production applications on a single machine, you've got all those things sort of competing with each other. And it could be that you might have some applications that conflict with each other. For example, you might need to run 2 different versions of an application, and the older version may not be able to run on the same, at the same time as the newer version because of conflicts. With virtual machines, you don't have that problem because virtual machines are sort of idealized, and you can install just the applications that you want on a virtual machine and have multiple virtual machines that are tailored for each application. And this way you avoid conflicts with libraries or with applications that don't allow you to run multiple versions at the same time. You can also provide a consistent environment for your applications. And what that means is that if you look at a classic farm that's been built up over several years, you may have older machines and newer machines. And the older machines may not load exactly the same operating system libraries, or they may cause your software to behave somewhat differently than it would on newer machines. Again, with virtual machines, that problem goes away because a virtual machine is a synthetic computer and is idealized. Your software should run consistently on a virtual machine regardless of the underlying hardware, as long as that VM image, that VM instance, will actually run on the compute node. An additional advantage is that you can run multiple operating systems at the same time. In a classic farm, it's usually necessary to partition the farm into multiple operating systems if you want to render across operating systems. And that means that you have an inefficiency because if you don't have any particular jobs that apply to one of your operating systems, that portion of your render farm may be sitting idle while the other portion is busy with work. With a private cloud, you don't have that problem because your compute nodes can pick up virtual machines, and the virtual machines can run nearly any operating system. So you get around that problem. You can actually get better utilization out of your render farm. There are some other advantages as well for private clouds in terms of simplifying IT operations. You can rapidly provision new hardware if your cloud is configured for that. And you can do other things like tell a particular compute node to evacuate all the virtual machine instances so that you can take it offline and do repairs or upgrades. And then when you put it back online, it will be repopulated with virtual machine instances and continue working. There are other advantages for IT as well, but those are somewhat secondary to the typical concerns of getting production work done on a render farm, so I will leave it at that. Now, in terms of a public cloud, and to draw the distinction, a private cloud is a cloud that's run inside your company on your company's hardware, and basically you control everything about it. Whereas with a public cloud, you're renting compute cycles from a public cloud solution provider like Amazon or Azure. There are some advantages there as well. You can use public clouds as an overflow to handle spikes in demand. Because they essentially have infinite scalability, you can fire up as many virtual machine instances as you like, up to whatever your budget or your bandwidth will support. I reached out to Jonathan Bryce, who's the executive director of OpenStack, and asked him for some statistics on cloud adoption over the recent years. And he provided me with these charts here, which show the amount of participation at each of their summits in terms of participating companies and overall attendance. And you can see that the growth is quite rapid and is in fact increasing in rate over time. And while these statistics are specific to OpenStack, I think that they are representative of cloud computing overall, and that we're seeing rapid adoption of cloud usage. So if you haven't made yourself familiar with cloud computing, I think you should do that so that you can keep up to date and take advantage of that technology. Okay, so how are jobs enabled for cloud processing? The answer is deadline groups and group mappings. So let's go take a look at that. And before we look at that, I'd like to point out that we turned on Azure and Amazon. We see a couple of Azure instances have picked up while I was talking. All right, so back to the question of how are jobs enabled. So we use the groups feature. So as you know, Deadline has this ability to create groups for job types. And this might be an example list of job types. Now, of these, you can choose which of these groups are enabled for cloud processing. To enable a group, you do that in the cloud provider configuration because you need to configure groups on a per provider basis. So for example, if we look at our OpenStack and we go to the group mappings option, we can see that I have 3 groups enabled. I've enabled Blender, Krakatoa, and Maya by simply adding a group. And you can also see that for each group I've selected a virtual machine type and a cost. And these can be edited, of course, to select whichever machine types are available for the cloud solution that region is enabled on, and the various image types that you may have prepared. And again, here is where you control the cost setting. Similarly, if I were to look at Amazon, I can see that I have two groups enabled here, Blender and Krakatoa. And for Azure, I've got Maya and Krakatoa. So in this way, you can choose which groups are enabled on which cloud regions to control what type of work is done where, and basically give you the flexibility that you need to control the work that's happening on the cloud. And additionally, we can see now that this slave here, which has a name starting with IP, is in fact an Amazon slave. So now we have both Azure and Amazon public clouds participating in our rendering. And again, to recap on the enabling jobs for cloud processing, essentially what you do is you assign a group mapping for a cloud region, and then you associate a VM image and a hardware type to that group. Now, how is work allocated to each cloud region? The answer is a new application that's part of VMX called the Deadline Balancer. And what the balancer does is it launches and terminates VM instances in each enabled cloud region based on the demand in the queue. So let's take a look at that. So this is the Deadline Balancer. And at the top, you can see the various cloud regions that we've enabled. So in addition to the classic slaves that you saw rendering, we've also enabled OpenStack, Azure, and Amazon. And you can expand each of these to see which groups are enabled, and you can expand each group to see which hardware types and virtual machine image types that you've assigned. In the lower portion of the balancer application, you can see the log, which is showing the stages that the balancer goes through. And essentially goes through three different stages. The first stage is, if I back up here a little bit, the updating of the state. So what the balancer does is it looks at the queue, and it looks at all the cloud settings that you've put in place, and it gathers up all the information about the jobs and cloud settings, and basically prepares them to be handed off to an algorithm. And what the algorithm does then is it looks at all that information and decides how many virtual machine instances for each group that's enabled should be launched. It comes up with a target number for each of those groups. So here we can see that it's favoring Krakatoa quite heavily because of the amount of Krakatoa jobs in the queue. Finally, once the targets are arrived at through the algorithm, those targets are passed back to the balancer's equalization stage, where it then goes out to each cloud provider and ensures that the correct number of VM images or instances are running in that region. And if it's not, if that region is running too many instances, it will shut some of them down. If it's not running enough instances, it will spawn more of them up in order to conform to those targets within your budget settings. So now that we have the ability to spin up work on various cloud providers, how do we manage the costs and resources? The answer is that each cloud region has a budget that you set, and each group mapping has a cost that you set. So I'll show you how that's done. Let's go back to the cloud provider configuration. Let's look at the Amazon public cloud. And I mentioned previously that there's a region budget setting here. In this case, I've set the budget at 0.24, which we're interpreting here as meaning 24 cents per hour total. If you go to the group mappings where you've enabled various groups, you can see that there's a cost with each associated with each group type that's been set in the cost settings. If I go back to the edit settings, you can see where that's set. Down at the bottom here is where you choose the cost. And here, what we're saying essentially is that the medium instance costs 12 cents an hour. Similarly, this Blender group is assigned a micro instance, and that's assigned 6 cents an hour. And the way to think of this is that the cost is a sort of size of a marble, for example. And the overall budget is the total number of marbles sizes, marble volume that you can have at any given time. So that means that you can run various combinations of these groups as long as the total number of instances, multiplied by their cost, does not exceed the total budget. I should also point out, for example, if I go to our OpenStack private cloud, that the budget settings are, the units of budget are arbitrary. For Amazon, I was using cost in terms of cents per hour, but for our private cloud, I'm simply using simple units, meaning I've assigned a cost of 1 to each of these various machine types for each of these groups. And I can only have a total of 4 in my budget. So that means I can run up to 4 instances in this case, because each instance has a cost of 1. And that is essentially how you can control cost in this manner. What if the assets for a job do not exist in a region's local storage? The answer is asset checking can be enabled on a per region basis so that jobs whose assets do not exist will not be eligible. Let me explain that in a little bit more detail. And let's go back to the cloud provider settings. If you're running a private cloud, chances are, for example with OpenStack, chances are that private cloud has access to your local storage. In that case, it's safe to assume that the assets are available to the virtual machine instances that are running in the private cloud, and there's no need to check for whether an asset is available or not. However, if you're using a public cloud like Amazon or Azure or other public cloud providers, you'll need to get your assets up into that cloud region in order for the jobs to be able to process. And what you don't want to happen is you don't want those jobs to be failing because they don't have the assets available. We have a small application that runs in each cloud region that's called the asset crawler, and what it does is it keeps an eye on the assets that have been uploaded to that cloud region, and it can essentially see the same assets that a slave running in that cloud region can see. And when asset checking is enabled here, VMX Balancer will, when it's considering whether a job should be counted towards the weighting, the algorithm decides how many instances should be started. It will go out and talk to the asset crawler in a given region and ask whether the assets for that job are available. If the assets are not available, then it will skip over that job for consideration for rendering in that particular cloud region. Or if the assets are available, then it will be counted towards the target allocation. And that's essentially how you control whether or not asset checking is enabled, and you prevent lost time due to assets not being available in a given region. So now I'd like to talk about some advanced customization features of VMX. What if the cloud provider I want to use is not listed? Well, you saw previously a very long list of cloud providers. However, there's new ones being added every day, and perhaps you want to add some additional functionality or hooks or triggers into the cloud providers that are already supported. Well, the answer is that the cloud provider support is implemented via plugins, and plugins are written in Python. So what that means is that if a provider you want is not listed, you can create your own plugin, or you can reach out to us to create the plugin. And in that way, as long as a given cloud provider has an API and has sufficient functionality to launch and terminate VMs and get their status, then that cloud provider can be controlled through VMX for Deadline. Now, what if I want the allocation of VM instances to happen differently? I showed previously the VMX application, going through the algorithm stage. It turns out that algorithm is implemented also as a plugin, and that means that if you don't like the algorithm that's being used, you can choose a new one. So let me first go back to the VMX Balancer window, and again point out, for example, we have the 3 stages. So up here again is the updating of the state. The state is gathered up and passed over to the algorithm, and essentially that algorithm can be changed to do whatever it is that you need it to do. And all that the algorithm has to do is provide a set of targets for each enabled group, and then those targets are handed over back to the balancer, which then goes through an equalization stage to conform the various regions to those targets. And I would point out too that if your algorithm happens to have a bug, for example, and chooses targets that are unreasonable, say for example it tries to spawn thousands of slaves for a different group, the equalization stage will always respect the budget settings that are set in the cloud provider configuration. That way, if if a value for the targets is unreasonable, the targets will be clamped to whatever is permitted within the budget. Now, the algorithm can be selected in the cloud provider settings. Or in the balancer options. That's just under the cloud provider settings. Here is the configure VMX balancer options. Currently, we're using the default algorithm, which uses a weighting algorithm based on the number of tasks in a different group, as well as the priority of the jobs that own those tasks, and it arrives at the various targets for each group. However, this is where you would select a custom algorithm, and you can provide your own UI as well. So if you have controls that you need to hook into your pipeline, or read values from yet another server somewhere, you can provide those options if you need to. And that essentially is VMX for Deadline. And to recap, the theme was render anywhere, local, public, and private clouds. You can mix in the cloud rendering at your own pace. You don't need to choose one or the other. You can control which jobs render in which clouds with the groups features. You can control usage and cost with the budget controls, and you can prevent wasted cycles with the asset checking feature. You can balance resources whenever you have a fixed resource, such as a private cloud, and you can scale instances if you're using a public cloud based on the demand in the queue. And if you reach the budget, of course, then it will balance within the budget. And finally, if you don't like the algorithm that's used to arrive at the various targets, you can customize that. Or if you need to add an additional cloud provider that isn't listed, you can do that as well with our customization. I'd like to conclude the demo by going back to the queue. Notice now that we have several Azure and Amazon instances running. If I wanted to, I could bump up the budget for Azure, for example. Let's say we get some funding in and we want to we need to get things done a little faster, and we have budget approval. We'll double the budget approval there and go ahead and specify more instances of Azure to help contribute to the rendering process. As the balancer goes through its next cycle, it will see that the budget's been increased and will start allocating additional Azure slaves. I would point out again that there are actually 5 different networks participating in this demonstration. There's the classic render farm that we have set up in the traditional fashion. There is the small OpenStack private cloud that's participating, the Amazon public cloud instances, as well as the Azure public cloud instances. And it's all being controlled from a secret undisclosed location in the southwest United States. So that's quite powerful, and of course you could add additional cloud regions if you wanted to. That concludes the demonstration for VMX. If you have any other questions, feel free to visit our discussion forums at forums.thinkboxsoftware.com and post your questions there, and we will get you an answer. Thank you very much.